Hello again, everybody. Welcome back to Beginning Algebra. Today we are in section 1.2 and we're going to be talking about variables, expressions, and equations. And we're still in this pretty much introductory phase where we're laying some good foundation so we'll be able to build some skills later. So this is still not very difficult, so don't try to make it anything hard or complicated here. We're still very much on an introductory level. So today we're going to talk about evaluating algebraic expressions when they give us a value for the variable. And we're going to practice translating word phrases into algebraic expressions. We're going to learn how to identify the solution of an equation. Now, I want to point out that we're not learning how to solve equations today. That will come later. But we are going to learn how to take two or more numbers and figure out which ones are solutions to an equation. We're going to practice translating sentences into equations, and we're also going to talk about distinguishing between equations and expressions. And this is a really simple idea, but if you don't know the difference between an equation and an expression, then you will make goofy mistakes all the way through algebra. So although this is really easy and kind of common sense, we are going to talk about it for a few minutes. Here we go. Now, first, a little bit of vocabulary. Our first new term is the word constant. A constant is just a fixed, unchanging number. A few examples of constants would be numbers like 5, -8, 1.4, or 5/9. Really, any number you can think of that's not multiplied by a variable is considered a constant. Now, a variable is a symbol that's used to represent an unknown number. Usually it's a letter because those are easiest for us to write and type and say, but it wouldn't have to be a letter. So I want to really fight against this thing that I hear people say all the time, which is that I was doing fine with math until they threw letters in there, and letters don't belong in math. Well, I have good news for you today because there are no letters in math. These letters that you see in your math problems, they are just representing an unknown number. So math problems contain only numbers. The letters are incidental. You could use a smiley face or a square or a check mark or really any symbol you want, but you have to have some symbol to stand for that unknown number. So that's all a variable is. So again, remember, there are no letters in algebra. There are only numbers and symbols that stand for unknown numbers. And all the numbers have to follow the same rules, whether they're known or unknown. So whether it looks like a number or whether it doesn't, they all have to follow the same rules, like our order of operations that we learned earlier, or like some of the properties that we'll talk about in an upcoming section, all of the sign rules that we're going to learn later. So that should reassure you a lot. It's not going to be as complicated as a lot of people have tried to make it, because if you can learn the rules that all the numbers have to follow, then you can do anything in algebra no matter how many letters there are. Now here's another term. An algebraic expression is a sequence of constants, variables, operation symbols like addition, subtraction, multiplication, and division, and or grouping symbols like parentheses, brackets, or fraction bars. Now, just to be clear, an algebraic expression does not have to contain all of these things, but it will always contain some combination of these things. Here are a few examples of algebraic expressions. This says x plus 5. So what this says is some unknown number plus 5. It's not telling us what this expression equals. Notice there is no equals anything here. This is just an expression, and you can't use this to find out what x equals. In other words, you cannot solve this. It just simply says an unknown number plus 5. That's all it says. And here's another one. This one says 2m minus 9. So this is saying take some unknown number, multiply it by 2, and then subtract 9 from that product. And then here's a little more complicated one. This time the variable is q, so q stands for some unknown number. It says take that unknown number and square it, or multiply it times itself, then multiply that number times 8, and then add 6 times the number minus 2. And so this again is just an algebraic expression. If they would tell us what the value of q is, we could replace the variable with that number and use order of operations to find out the value here. And that's exactly what we're about to do. Now, the process I just described of plugging in a value and then using order of operations to find out the value of the expression, that's called evaluating. To evaluate an expression is to find its value. And an algebraic expression can have different numerical values for different values of the variable. So here's example 1, and it says evaluate each expression for x equals 5. So in every expression, we have an x, which just stands for an unknown number, and they're telling us that x is 5. So in every case, we're going to replace x with 5 and then evaluate. So 8 plus x becomes 8 plus 5, which we know is 13. It's that simple. Okay, now this says 8x. Now you may have noticed before that whenever there's no symbol in between the two numbers, it stands for multiplication. So we could put a dot here, but traditionally we just don't. 8x means 8 times x. So this is going to become 8 times 5. Now notice that here I used parentheses as my multiplication symbol, but I could have just as easily put 8.5 and not had the parentheses. That is totally up to you. I like the parentheses because they're harder to overlook. It just seems clearer to me. So I almost always use parentheses. But now 8 times 5 is 40. See, that's all there is to it. All right, now this says 2x minus 9. So remember, x is 5. So this says 2 times x. That's going to be 2 times 5, and then minus 9. Now, if you remember your order of operations, multiplication has to come first. So 2 times 5 will be 10, and then 10 minus 9 is 1. So the value of this expression is 1 as long as x equals 5. And here we have 3x squared. So now remember, x is 5. So now this is going to say 3 times 5 squared. Now just as a reminder, remember the exponent can only affect the number that it's next to. And if you think about PEMDAS, you think about our order of operations, exponents have to be handled before multiplication. So we would not multiply here first. We would deal with this exponent first. And this exponent is only affecting the 5. So 5 squared is 5 times 5, which is 25. And then 3 times 25, of course, is 75. So again, just a caution for you. Remember that the exponent only affects the value that it is next to. So 3x squared is equal to 3 times x. It's not 3x times 3x. It's not the whole 3x that gets squared. It's only the x that gets squared. If you wanted an expression to mean 3x times 3x, you would need to put the 3x in parentheses and put the exponent there to get 3x times 3x. So you see the difference? This one has parentheses, so everything in the parentheses gets repeated. This one does not have parentheses, so only the x gets repeated. Now in example 2, we're going to do the same thing that we did in example 1, only this time we'll have 2 different variables. And in this case, they're telling us that x equals 5 and y equals 3. So we will evaluate each expression given that x equals 5 and y equals 3. Okay, here we have 2 times x plus 5 times y. Now we know that x is 5 and y is 3, so I'm going to write 2 times 5 plus 5 times 3. And you can see here I used the dots instead of the parentheses just to show you that you can do that. Again, I usually use parentheses. Now 2 times 5 is 10, and 5 times 3 is 15. And remember, when we're showing the order that we're doing our steps in, we always underline the step we're going to do, and then on the next line we show the result of that. So I did the multiplication, and now I'm ready to do the addition. 10 plus 15, of course, is 25. In part B, we have a fraction bar, so in this case we work the top and the bottom separately. Now, because I was short on space, I didn't write out the words top and bottom like I did for you in the last section, but we still can do them separately. So what I'm going to do is put 9 times 5 minus 8 times 3, and then my fraction bar, and then in the denominator 2 times 5 minus 3. Okay, we know that multiplication comes before addition and subtraction, so I'll go ahead and in each case I will do the multiplication. So 9 times 5 is 45, 8 times 3 is 24, in the denominator 2 times 5 is 10, and then we have our minus 3. And then I can do the top subtraction and then separately the bottom subtraction. 45 minus 24 is 21. In the denominator, 10 minus 3 is 7, and we know that 21 divided by 7 is simply 3. And now for part C, remember x is 5 and y is 3, so we will have 5 squared minus 2 times 3 squared. And again, notice that the 2 exponent is only going to affect the 3. We can't do the multiplication here until after we've taken care of the exponent. So first we will deal with exponents. 5 squared is 5 times 5, that's 25. 3 squared is 3 times 3, that's 9. So we have 25 minus 2 times 9. Now we'll need to do the multiplication. 2 times 9 is 18. And so now we have 25 minus 18, which is 7. Okay, now we're ready to move on to our second objective, which is translating word phrases to algebraic expressions. This is very common sense. You'll read the phrase and you'll think about what it means, and then you'll write it down in math notation. It's not difficult, but it is an important skill, so let's just practice. Now notice that the instructions say write each word phrase as an algebraic expression using x as the variable. So they are telling us here what symbol should stand for the unknown number. Alright, we'll be sure and use x as we go through each of these exercises. This first phrase says the sum of a number and 9. Now we know that the word sum stands for addition. And here we have an unknown number, and remember they've asked that we use x as the symbol for the unknown number. So I'll write down x plus 9. So this is the algebraic expression that represents this phrase. Okay, part B says 7 minus a number. And again, the symbol that we use for the unknown number is x. So simply 7 minus x. And that's all there is to it. This algebraic expression represents this phrase. And for part C, we have a number subtracted from 12. Now, if you subtracted from 12, it means you started with 12 and you took away this unknown number. So let's write down the 12 first, and then we will subtract x. Now let's do a few more together because we just want to get all the practice with this idea that we can. Here in part D it says the product of 11 and a number. So the word product, you know, means multiplication. So the product of 11 and a number would just be 11 times x. And we really don't even need the dot here. We could just write 11x. Okay, now part E says 5 divided by a number. Remember, the fraction bar takes the place of the division symbol. So divided by is just going to be represented by a fraction bar. And we'll have 5 divided by a number. 5 divided by a number. And then in part F it says the product of 2 and the difference of a number and 8. Okay, so product means we're going to be multiplying. And the difference of a number and 8 means we need to subtract these two numbers. So the difference of a number and 8 would be x minus 8. See, that is the difference, subtraction, of the unknown number and 8. And now we want to multiply this difference times 2. So product means multiply. But how can I show that this entire expression is to be multiplied by 2? Well, we can use parentheses for that. So we'll put our expression in parentheses and then multiply it by 2. See, this is the product of 2 and this difference here, which is the difference between the number and 8. Okay, now we're going to shift to a new objective and we're going to talk about identifying solutions of equations. Now, first we need to figure out what an equation is. An equation is a statement that two expressions are equal. So in an equation, you have an equal sign and then you have an expression on the left and an expression on the right. An equation always includes the equality symbol, which is the equal mark. Here are a few examples of equations. X plus 4 equals 11. See, on the left, our expression is x plus 4. On the right, our expression is just 11. And the equal mark tells us that this expression has the same value as this one. Here's another example of an equation. We have 2 times an unknown number equals 16. So they're telling us that 2 times this number has the same value as 16. Here's another equation. I know it's an equation because it contains an equal mark. So 4 times an unknown number plus 1 is equal to 25 minus that unknown number. And here are a couple more equations. 3/4 times an unknown number plus 1/2 equals 0. And an unknown number times itself equals 4. Now for each of these equations, we could figure out what the unknown value would have to be so that the two sides match. You'll spend a lot of time in algebra learning how to solve different types of equations. Right now, all they're going to do is give us a number and ask us if that number can make the equation true. In other words, they'll ask us, can this number be a solution of the equation? So let's look at example 4. It says decide whether each equation has the given number as a solution. Okay, so part A says, is 7 a solution of 5p plus 1 equals 36? In other words, if p equals 7, does that make the equation true? Well, let's put a 7 in here and find out. So if 7 is the solution, then 5 times 7 plus 1 should equal 36. And let's see, multiplying 5 times 7, we get 35. And 35 plus 1 is 36. And that does have the same value as the right side. And therefore we say yes, 7 is a solution. A solution is a number that makes both sides have the same value. In other words, a solution is a value that makes the equation true. And part B says, is 14/3 a solution of 9m minus 6 equals 32? Well, I don't know. Let's put 14/3 in place of our unknown number, and then we'll have 9 times 14/3 minus 6 equals 32. So we want to simplify the left side and see if the left side matches the right side. Now, 9 times 14, I don't know in my head. I know that's going to be a larger number than we usually deal with. So I would not do this multiplication. Instead, I would simplify first. I would say 9 divided by 3 is 3. And 3 divided by 3 is 1. See, that gets rid of those large numbers. So now 3 times 14, it's easy to work that out. 3 times 14 is 42 minus 6. And that's going to equal 36. 42 minus 6 is 36. That is not equal to the right side, so there's no match, and therefore 14/3 is not a solution of this equation. You see how that works? If we plug the number in and work it out, if the left side doesn't match the right side, that number was not a solution to that equation. Now here are a couple for you to try. I hope that you'll pause the video and try these on your own, because doing it yourself is not the same as watching me do it, and you'll really benefit from doing it yourself. Okay, now if you've done it yourself, let's go through this together. Is 7 a solution of 2k plus 3 equals 15? Well, let's plug our 7 in place of our unknown number and see what happens. So we'll have 2 times 7 plus 3 equals 15, and we want to find out if this is true. So 2 times 7 would be 14, and then 14 plus 3 would be 17. And 17 is not the same as 15. Therefore, the left side does not match the right side, and therefore we know that 7 is not a solution of this equation. And for part B, we have, is 16/7 a solution of 7p minus 11 equals 5? Okay, well, let's plug 16/7 into our equation in place of our unknown number. And the first thing we are going to have to do is 7 times 16 over 7. But I don't want to have to work out 7 times 16, so I just noticed that there's a 7 in the top and a 7 in the bottom, and that means they are going to cancel each other out. Or in other words, we can simplify this, get rid of the 7s, and now we have 16 minus 11, and we know that 16 minus 11 is 5. That does match the right side, and therefore, yes, 16/7 is a solution of this equation. And now we come to our next objective, which is translating sentences into equations. This is similar to when we translated phrases into algebraic expressions. It's just that this time we will get an equation instead of just an expression. It says write each word sentence as an equation. Use x as the variable. So part A says twice the sum of a number and 4 is 6. So the word is going to be your tip-off that you're dealing with an equation here. So let's look at this phrase, twice the sum of a number and 4. Now, one thing that I think will be helpful to you is to always start writing with the unknown number. So since this says the sum of a number and 4, that's the part I'm going to start with. Okay, sum means addition. So the sum of a number and 4 is going to be x plus 4. Now twice that means to multiply this sum by 2. So in order to get the whole sum multiplied by 2, we'll need parentheses. So twice the sum of a number and 4 is 6. So 2 times x plus 4 equals 6. Represents this word sentence. Now let's look at part B. 9 more than 5 times a number is 49. Now remember, it's a good idea to start by writing the part with the unknown. So when we look at 9 more than 5 times a number, we see we have to start by writing down 5 times a number. Now how can we write 5 times a number? Well, that would just be 5x. See, that's 5 times some unknown number. And then 9 more than that would be to add 9 to that product. And then it says 9 more than 5 times a number is 49. So is 49 means equals 49. And that's all there is to that. And then let's look at part C. 7 less than 3 times a number is equal to 11. So we're going to have to take 7 away from 3 times a number. Now how can I write 3 times a number? We'll just have to write 3 times x. Now to get 7 less than that, we'll have to take 7 away. So this is 7 less than 3 times a number, and that is equal to 11. So equals 11. And that's the translation for that word sentence. Here are a few more for us to practice on, and I thought it would be good for us to see several of these. So if you would like to pause the video and try these on your own, you're totally welcome to. You may run into a couple of situations we haven't talked about yet, but it won't hurt you to try. So let's go through these together. This says 3 times the sum of a number and 13 is 19. So remember, it's a good idea to start by writing down the part that contains the unknown. And my unknown number is here, where it says the sum of a number and 13. So I can write the sum of a number and 13 by saying x plus 13. Now 3 times that would mean to take that whole sum and multiply it by 3. And then it says that is 19. So just write equals 19. Here's part B. 5 times a number subtracted from 21 is 15. So again, start where you have your unknown number. And this says a number subtracted from 21. Now that means you've got to start with your 21 and take this unknown number away from it. So that's going to be 21 minus our unknown number. See, that's a number subtracted from 21. Now 5 times that means I've got to put this whole thing in parentheses and multiply by 5. And then that whole thing is 15, so equals 15. For part C, we have 5 less than 6 times a number is equal to 19. So again, start with your unknown. Here we have 6 times a number. So this represents 6 times a number, and then we need to say 5 less than 6 times a number. So we take that 6x and we take 5 away from it. And then it says that is equal to 19. Now I have seen some people before try to use a less than symbol here. Like they might want to say 5 less than 6 times a number equals 19. But this doesn't make sense. For one thing, because it's got an inequality symbol and an equality symbol, and you can't have something like this in an equation. So the difference is that this doesn't say 5 is less than 6 times a number. See, it's not trying to get you to put some kind of equality or inequality symbol. It says 5 less than 6 times a number. So the words less than indicate subtraction. And if we had is less than, then that would give us an inequality, but that's not what we have here. So now let's look at part D. 15 divided by a number equals the number minus 2. So I think this is the first time that we have the number appearing twice. So remember, divided by will represent with a fraction bar. So here we'll say 15 divided by a number equals, so equal mark, a number minus 2. So the number is x and then minus 2. 15 divided by a number equals the number minus 2. Okay, now I want us to really focus on the difference between equations and expressions. And again, if you understand the difference between equations and expressions, then everything is so much easier for you. And if you don't understand this difference, then you'll be able to do a lot of things in algebra, but you'll always be making goofy mistakes. So we want to prevent that. An equation is a sentence. It has something on the left side, and then it has an equal mark, and it has something on the right side. An expression, on the other hand, is a phrase that represents a number. So that's a really good way to look at it. An equation is like a whole sentence, and an expression is just a phrase. It's not a whole sentence. The dead giveaway of the difference between an equation and an expression is that an equation has an equal mark in it. It is that simple. So we're going to decide if each of these is an equation or an expression. This says 2x minus 3 minus 8. Okay, the first thing I notice is that there is no equal mark here. This is not a sentence. It cannot be solved. It can't be made true or false because it's not a whole sentence. So this is an expression. And then in part B we have 2x minus 3 equals 8. Now that is a sentence, and we see the equal mark. So the fact that we see an equal mark means we are dealing with an equation. This can be made true or false based on the value of x. If we have the right value of x, the sentence will be true, and if we don't have the right value of x, it will be false. So this is an equation. And then in part C, we have 5x squared plus 2y squared. There is no equal mark here. And because there's no equal mark, this is simply an expression. And again, it can't be made true or false because we don't know what it equals. And that's all there is to this lesson, guys. We're getting closer and closer to being able to really build up some algebra skills. We just have a few more sections to go before we're out of this introductory phase. So be patient, keep taking step by step, think about what you're doing, always read the instructions. One problem a lot of algebra students have is they don't read the instructions, and therefore how can they follow them? So make a practice of reading what you see, not just looking at problems. And that's it. I'll see you next time.